Okay, so this is algebraic inequalities. Now this is a question which seemed to cause an awful lot of confusion. Okay, I think it's something that we need to revise over. But I'm going to just begin with talking to you about this first. So show the inequality 6 minus 4x is less than or equal to 26, where x is an element of the integers. Now, that's something we need to know because it's important here when we're doing the number line. Integers means positive or negative whole numbers. So let's write that down. Z. It's positive and negative whole numbers. So that means the solutions to this is only going to be positive or negative whole numbers. Now the idea of an inequality is that it has more than one solution. So for instance, 3 greater than 5, or something, we'll say rather, 3, what am I doing? Something greater than 5. 6. So if we confine it to the natural numbers, so the numbers that are just positive whole numbers, we have 6, 7, 8, 9, 10. Okay? It just means in terms of this, we have more than one solution to the problem. So let's go down to actually solving the problem we have. So we have 6 minus 4x less than or equal to 26. Now the big thing with inequalities is if we multiply across by a negative, we have to change all the signs, including the way the inequality sign is facing. So if it's saying greater than, it's now going to say less than if we're multiplying across by a negative. Now, train tracks, it's a linear thing that we're solving. Let's isolate the x. So let's go minus 6. So we have minus 4x less than or equal to 20. All of you can do that first step, no problem. Now the next thing is we're going to change the sign. So we're going to multiply across by a negative 1. Multiply across by a negative 1. So we're going to have 4x greater than or equal to minus 20. See how that happened? So we flipped the inequality sign and we changed all the signs everywhere else. Now again, I still want to solve it for x. So I'm going to do divide by 4 on both sides, and I have x greater than or equal to minus 5. So then that's it. That's us solved. That's our solution. We're happy. It's an integer. Okay, minus 5 is an integer. It's a negative whole number, but that's still an integer. So on the number line, and the one we had been given, started at minus 6, minus 5, minus 4. Now you were lucky enough, you were given it. Just when I tested this out, you couldn't read the page when I was doing it on the exam papers, so you're lucky. Now, if x is greater than or equal to minus 5, or equal to, so that means we're happy that's minus 5. Greater than, so it's going to be 0. 0 is greater than minus 5. It's going to be 1, it's going to be 2, it's going to be 3, and so on and so forth. So that's why I put in the arrow in the same, containing the same way. Now it's also going to be all these places in between. I'm doing dots here because it cannot be minus 2.5, because minus 2.5 is not an integer. It can only be on the positive or negative whole numbers, and that's where it satisfies the inequality. And we have to just think of what type of number they want in the inequality. Now I would like you to try a good few of those. There is a lot in book 1. There's also a good few in the exam paper questions at both Leaving Cert Ordinary level and Junior Cert Higher.